Hi everyone. Welcome back to our new episode. If you joined us last time, you'll remember that we had a deep dive into the extraordinary advancements in artificial intelligence. We explored how AI is rivaling human capabilities across various domains, the meteoric rise of deep learning networks like transformers, and the explosion of research publications fueling this progress. It was a conversation that highlighted not just how far we've come, but how fast AI is shaping our world.
That's right. And today we're shifting gears to another transformative force in technology, the Internet of Things, or IoT. We'll discuss how IoT is converging with AI to power smart cities and green cities, the high-level architecture of IoT systems, and the data that drives these innovations.
Right. We'll also discuss how IoT is redefining how we interact with the world around us, from intelligent homes to sustainable urban planning. We will also focus on how AI enhances these systems, making cities smarter, more efficient, and more sustainable.
As always, our guide for this journey is Dr. Alok Agarwal's insightful book, The Fourth Industrial Revolution and 100 Years of AI. It's a fantastic resource that connects the dots between these emerging technologies and their impact on our future. So get ready for a fascinating discussion about the intersection of IoT, AI, and the cities of tomorrow. Let's dive in.
So the big question is, what's happening with the Internet of Things? How is it transforming our world today, and where is it heading?
I think the first thing that really hits you is how massive it is. We're talking like 15.4 billion devices just in 2023, far surpassing the 5.5 billion smartphone users. It's not just about convenience anymore. It's reshaping entire industries and how we live.
And the innovations are groundbreaking. Agarwal mentions ingestible sensors, pills that can detect stomach bleeding using iron-sensing bacteria. These bacteria emit light when they detect blood, and the pill transmits that signal.
It sounds like science fiction, but it's real and undergoing trials right now. What's even more fascinating? These sensors are powered by stomach acid. It's an incredible example of IoT merging biology and technology, breaking boundaries we didn't think were possible.
It's amazing to imagine the future possibilities with this kind of technology. So, where do we even start with something as massive as IoT?
A good starting point is understanding the layers of IoT architecture. Think of it like a well-organized factory, where each layer has a specific role in transforming raw data into actionable insights.
All right, let's begin with the foundation, the edge devices. These are the field gadgets gathering the data, right?
Exactly. Edge devices range from smart thermostats to cameras monitoring traffic, sensors tracking air quality, or smart meters measuring water usage. They're incredibly diverse and operate in tough conditions, extreme temperatures, humidity, vibrations, while relying on limited power and processing capabilities.
So these are like tiny warriors out in the field, battling harsh environments to bring us information. And they're not just collecting data anymore, they're starting to analyze it too.
That's right. Processing data at the edge is becoming crucial, especially when quick action is needed. For instance, a smart security camera can analyze video feeds and send alerts for intrusions without waiting to process the data elsewhere.
Impressive. But with all these devices speaking different languages, how do we make sense of it all?
That's where gateways come in. Think of them as the master translators of IoT. Their job is to convert various data formats and protocols into a universal language that the rest of the system can understand.
So they create a common language for all devices.
Exactly. And it's not one size fits all. Different gateways are designed for specific needs, like handling high-volume data streams or supporting low-power devices. Some can even process and filter data at the edge to reduce the load sent back to the cloud.
That's pretty smart. But even with this translating and filtering, we're still talking about massive amounts of data. How do we organize it all into something useful?
That's where the interoperability and data unification layer comes in. This layer organizes and processes the raw data, turning it into valuable insights we can actually use. Basically, making sure all these different devices and systems can talk to each other, regardless of their protocols or data formats.
So, it's not just about translating languages anymore, it's about connecting all the parts of the system.
Exactly, like building bridges between islands of data.
That's a great analogy. What's next?
The second step is data unification. Think of raw data like scattered jigsaw puzzle pieces. This layer organizes and cleans those pieces, putting them together to create a complete picture, a single source of truth.
So it's about making the data accurate, consistent, and easy to access for analysis and decision-making.
Exactly. Without this step, the data would be practically useless, like a library full of books with no catalog to find what you need.
Makes sense. So after we've collected, translated, cleaned, and organized the data, what's next?
That's where the data operations and analytics layer comes in. Here, we turn the data into actionable insights, even predicting future trends.
Sounds powerful. What happens in this layer?
First, we decide how the data is stored based on its urgency. Critical, real-time data goes into hot storage, like an express lane for instant access, essential for reacting to events immediately.
And what about data that's not as urgent?
That's where warm storage comes in, for data we need access to but not instantly, like historical trends or pattern analysis. Finally, there's cold storage, for rarely used data we keep just in case, like old photos in your attic.
Got it. So, data is stored based on its importance and accessibility needs, but the real value comes from analyzing it, right? And this is the layer where the data really comes to life.
Exactly. It's everything from simple calculations, like averaging sensor readings, to advanced machine learning algorithms that can predict equipment failures or optimize resources.
Can you give us some real-world examples?
Sure. In a smart factory, analytics can monitor production lines, identify bottlenecks, optimize workflows, and reduce downtime. In agriculture, sensors and analytics help farmers monitor soil conditions, optimize irrigation, and even predict crop yields.
That's incredible. Real insights driving real actions. But how do these insights reach the people who need them?
That's where the interface layer comes in. It's the bridge between all this data and the users. This layer focuses on creating user-friendly dashboards to visualize trends, developing intuitive controls for devices, and building APIs for seamless system communication.
So it simplifies the complexity, making the data actionable and understandable.
Exactly. It's about delivering the right information to the right people at the right time in a way they can use.
Got it. So, we've journeyed from edge devices through data processing and analysis to these user-friendly interfaces. It's a highly interconnected system.
And one that's constantly evolving as new technologies and applications emerge.
Speaking of evolution, what's next for IoT architecture?
One big trend is edge computing. Instead of sending all data to a central server, more processing happens at the edge, on the device itself. This reduces latency, improves security, and optimizes bandwidth, which is crucial for applications like autonomous vehicles, industrial automation, and remote healthcare.
So edge computing brings the power of the cloud closer to the action. Are there other trends to watch?
Definitely. Artificial intelligence is becoming more integrated with IoT. Devices are not only collecting data, but learning from it and making decisions in real time.
That's a huge leap. But with all this complexity, how do we ensure these systems are secure?
Security is critical and must be built into the system from the start. This includes authentication, encryption, and regular updates. It's a multi-layered approach that also considers system resilience, handling sensor failures or connectivity issues without major disruptions.
That makes sense. But beyond security, what about ethical concerns? We're collecting massive amounts of data and building intelligent systems. What ethical issues should we be addressing?
Ethical considerations are crucial. We need to think about privacy, algorithmic bias, and the potential for misuse. It's not just about the technology itself, but how we use it responsibly.
So it's not just about technology, it's about the ethics and its impact on society.
Exactly. IoT is a powerful tool, but we have a responsibility to ensure it's used thoughtfully and responsibly.
We've touched on the risks, but let's shift to the incredible things IoT is already achieving. Dr. Agarwal highlights its transformative role in agriculture.
Absolutely. Agriculture is seeing a revolution through precision farming. Sensors across a farm measure soil moisture, nutrient levels, crop growth, and pests. This data allows farmers to make informed, precise decisions.
So instead of relying on tradition or guesswork, they're leveraging real-time insights.
Exactly. And beyond improving efficiency, precision farming reduces environmental impact. Less water, fewer pesticides, and herbicides.
That's a win-win for farmers and the environment. How about manufacturing? How is IoT driving change there?
Manufacturing is embracing smart factories where sensors monitor every aspect of production. These systems can optimize workflows, predict machine breakdowns, and even adjust production to meet demand.
So it's like having a virtual team ensuring everything runs smoothly.
Exactly. The result? Greater efficiency, minimal downtime, and increased productivity.
It's amazing how these small devices are transforming entire industries. What about transportation? Dr. Agarwal mentioned some exciting developments there.
Absolutely. Smart traffic systems are already easing congestion and improving road safety. Sensors monitor traffic in real time and adjust signals to keep everything flowing.
It's like a massive brain coordinating all the vehicles in a city.
Exactly. And imagine the future. Self-driving cars communicating with each other and the infrastructure around them.
That sounds like science fiction.
It does, but it's closer than you think. The potential benefits are huge. Fewer accidents, less congestion, and accessible transportation for people with disabilities. It could redefine urban life.
Wow. So we've covered agriculture, manufacturing, transportation, and healthcare. It feels like IoT has no limits.
That's true. The potential is massive. From smart homes that adapt to us to smart cities optimizing resources and improving quality of life. It's an exciting time.
It is, but it's also a time to be thoughtful. We've talked about risks like privacy and security. How do we ensure this powerful technology is used ethically and for everyone's benefit? For example, take that ingestible sensor. Who has access to its data, and how can we prevent misuse?
That's a perfect example of IoT pushing ethical boundaries. We need to address these issues now, not after the technology becomes ubiquitous.
So what steps can we take to ensure IoT development is ethical?
First, we must stop treating privacy as an afterthought. Systems should be designed to collect only the data they absolutely need, nothing more.
Like starting with the question, what's the minimum data required?
Exactly. And whatever data is collected needs to be transparent. No more burying details in unreadable privacy policies.
But even with transparency, couldn't data still be misused?
That's where data governance comes in. We need clear rules about how data is used, shared, and accessed. For example, anonymizing data or restricting its use for unintended purposes.
So, strong policies and regulations are key.
Yes, but it's not just about laws. Companies must prioritize responsible innovation, and consumers need to demand transparency and accountability.
So, it's a cultural shift, embedding ethics into development and empowering users to hold companies accountable.
Exactly. IoT isn't just about building cool gadgets, it's about building a better world, a future shaped by our values.
It's an incredible opportunity to create something meaningful and lasting.
And that's what makes this moment so exciting. We have the chance to get it right.
But you have to agree, it's the world of AI and the Internet of Things. I mean, by 2025, we're talking about 1.63 trillion gigabytes of data coming from all these smart devices. It's like every book in the Library of Congress, billions and billions of times over. But it's not just the volume, right?
Exactly. It's about what we can do with all that data.
And real-world data is messy. Sensors can go offline and glitches happen. Does AI just fail when that happens?
Not at all. This is where AI excels. AI algorithms are like detectives. They find inconsistencies, fill in gaps, and fix errors.
So even with system hiccups, AI ensures the data remains usable.
Precisely. AI doesn't just process data, it transforms messy data into something reliable.
Where do AI and IoT together make the most impact?
One major area is in industrial settings, often referred to as the Industrial Internet of Things, IoT. Picture a steel mill with sensors monitoring everything and feeding data to an AI system.
What's the advantage of having AI at the helm?
Predictive maintenance is a great example. Imagine a pump showing subtle signs of wear, things a human might miss. AI analyzes vibration, temperature, and other data, predicting failure weeks in advance. Maintenance can be scheduled before anything goes wrong, avoiding costly downtime or emergencies.
So it's saving money and increasing safety.
Exactly. It's like having a crystal ball for your operations.
What about other scenarios, like an unexpected surge in energy demand during a cold snap?
Traditionally, adjustments would be manual and time-consuming. Now, AI can instantly analyze data like pipeline capacity and weather forecasts to adjust energy output in real time, preventing shortages and price spikes.
And beyond energy,
Inventory management is another big one. AI can analyze historical trends, current stock levels, and future demand predictions to ensure materials are always available when needed.
So, it's making systems more efficient and responsive.
Exactly. Together, AI and IoT are reshaping industries by making systems smarter, safer, and more adaptable. I mean, AI is transforming healthcare through the Internet of Medical Things, IoMT. We're talking about medical devices that don't just diagnose but can predict issues before they happen.
Like something out of science fiction.
Exactly. Imagine a hospital managing limited resources like MRI machines. AI analyzes usage patterns and patient needs to optimize their use, reducing wait times and making the system more efficient.
So AI becomes the ultimate scheduler. But what about its impact on patients?
Think about smart beds that detect tiny movements to predict falls, or systems that analyze vital signs to alert staff about potential problems.
That adds a whole new layer of safety.
It does, but AI-powered systems aren't without limitations.
Can they replace human doctors and nurses?
Not completely. AI is excellent at spotting patterns, but doctors and nurses bring intuition and expertise that machines can't replicate. It's more of a partnership than a replacement.
That balance is key. You mentioned something earlier about OPC-UA. What is that?
It stands for Open Platform Communications Unified Architecture. It's a standard that allows machines to communicate, creating a common language for IoT devices.
So it's foundational for things like digital twins, a virtual copy of a system.
Exactly. Without a standard like OPC-UA, building a digital twin would be chaos. It provides the structure for seamless data exchange.
What's the point of a digital twin?
AI uses it to predict equipment failures, optimize energy use, or simulate scenarios. For example, a digital twin of a city's transport system could test traffic flow or optimize bus routes.
That's impressive. And in healthcare, you mentioned AI predicting falls. How does it do that?
It's all about machine learning. AI is trained on vast patient data to recognize patterns, like subtle weight shifts when someone gets out of bed or changes in walking that suggest instability.
So it anticipates falls rather than just reacting?
Exactly. It learns to understand each patient.
But with AI predicting and analyzing so much, does it risk overshadowing human roles?
That's the critical question. AI is a tool to enhance human care, not replace it. Doctors and nurses bring judgment and empathy, which AI can't replicate. The best systems will integrate both for optimal care.
Wow, so we've talked about AI and IoT in factories and hospitals. What about how it impacts our everyday lives?
That's where consumer IoT comes in. Think about a smart thermostat. It learns your temperature preferences, adjusts automatically, and saves energy. Or smart security systems that distinguish between a friend and an intruder. Even smart appliances you can control from your phone.
It's amazing how these devices are becoming part of daily life. But how does a smart speaker even understand what I'm saying?
That's thanks to natural language processing, a type of AI trained on vast amounts of text and audio to understand and respond to human language.
So it learns how we talk. But with these devices collecting so much data, isn't privacy a concern?
Absolutely. Data privacy is critical as AI and IoT become more integrated. It's about being aware of the trade-offs and making informed decisions about sharing data.
That's an ongoing conversation we need to have. Now, what about transportation?
Transportation is one of the most exciting areas for AI and IoT. Imagine traffic flowing smoothly, fewer accidents, and sustainable, effortless travel.
Sounds like a dream. I'm picturing self-driving cars and smart traffic systems.
Exactly. It all starts with sensors, cameras, radar, LiDAR, gathering data to create a real-time understanding of the environment.
So the car has eyes, but it also needs to understand what it's seeing.
That's where AI comes in, processing sensor data to identify pedestrians, cyclists, and other vehicles. It can even predict movements to make split-second decisions.
How does it handle unpredictable situations?
By learning from vast amounts of driving data. These systems are trained on millions of miles, learning the rules of the road and how to navigate complex environments.
It's like teaching AI to think like a driver.
Exactly. And it keeps improving with every mile driven.
That's incredible progress. But are people ready to trust AI with driving?
Trust and adoption are challenges, both technically and socially. But the benefits, greater safety, reduced traffic, and accessibility for those unable to drive are enormous.
It's not just self-driving cars, right?
Correct. AI and IoT are revolutionizing public transportation too, making it more efficient, reliable, and user-friendly.
Transportation is on the brink of a huge transformation.
It truly is. From personal vehicles to public systems, AI and IoT are reshaping how we move through the world.
Can you give me an example?
Imagine bus stops showing exactly when the bus will arrive, or trains adjusting their routes based on passenger numbers.
So it's about using technology to make the whole system more efficient.
Exactly. And it extends beyond vehicles. We're moving toward smart cities, where traffic lights communicate with cars, infrastructure monitors itself, and everything connects to create a smoother, more sustainable environment.
Sounds like something out of a sci-fi movie.
It really is amazing.
But with all this technology, we need to remember that it's just a tool. It's up to us to use it responsibly.
Absolutely. AI and IoT have the potential to revolutionize industries, healthcare, transportation, and daily life. But we need to approach them thoughtfully, considering ethical implications and ensuring they're used for good.
Well said. The future doesn't just happen, we create it. As these technologies evolve, it's up to all of us to have meaningful conversations, make informed decisions, and shape a future where AI and IoT empower people and improve the world.
Exactly. So smart cities, just skimming through all this research, it's fascinating. Trillions of dollars in investments, futuristic designs, and entire cities being built from scratch. Looks like we're at a major turning point right now. More than half the world's population lives in cities, and by 2050, that's expected to reach 70%. And here's the kicker. Around 60% of the urban space we'll need by then hasn't even been built yet.
That's staggering. But when we talk about smart cities, what does that actually mean? Is it just adding technology to existing cities, or is it something bigger?
It's much more than just layering on tech. It's about rethinking how cities function entirely. Technology plays a big role. IoT sensors collecting data everywhere. But the heart of it is using that data to make cities more efficient, sustainable, and livable.
So it's less about flashy concepts like flying cars and more about optimizing city systems.
Exactly.
And it seems like investment in this area is enormous.
Huge. The International Finance Corporation estimates nearly $30 trillion in smart city investments by 2030. That's not just fancy gadgets. It's smarter energy grids, advanced data analytics platforms for resource management, and innovations in water and waste management.
That's exciting, but are there cities already putting these ideas into action?
Definitely. Take Barcelona, for example. They started integrating IoT into their infrastructure as early as 2007. They've implemented systems that help drivers find parking to reduce traffic, and even have smart trash cans that signal when they're full, optimizing waste collection routes.
So they're improving existing systems with tech. But what about these futuristic projects like entirely new cities?
Some countries are taking bold steps to build cities from scratch with smart tech at their core. For example, Saudi Arabia's The Line, a city designed as a straight line stretching 170 kilometers.
That's wild. What's the idea behind such a radical design?
Sustainability. Everything is within walking distance. And the city aims to be entirely carbon neutral. The project's budget is around $500 billion. It's ambitious, to say the least.
That's a massive investment. It's not just upgrading, it's redefining cities entirely. And Japan's also doing something groundbreaking, right?
Yes, Toyota is building Woven City at the base of Mount Fuji. It's designed with interconnected streets, separate lanes for pedestrians, driverless cars, and personal mobility devices.
So it's a city optimized for seamless movement and maximum efficiency. AI manages everything, from traffic flow to energy use in homes. It's a glimpse of how life in these cities could be vastly different.
Exactly.
It's easy to get caught up in the scale and tech of all this, but I keep wondering, how will smart cities actually impact people's daily lives? Is it just about convenience, or is there something deeper?
It goes beyond convenience. It's about creating cities designed for people. Think smoother commutes, less traffic, cleaner air with real-time pollution monitoring, and access to city services through a single app.
That sounds great, but all this data collection raises privacy concerns. Are we trading our privacy for convenience?
That's a critical issue. Strong encryption, clear consent rules, and strict regulations on data use are essential. City planners and policymakers must prioritize privacy.
It's a tightrope, using data to improve lives without overstepping. And we also need to ensure everyone benefits, not just a select few.
Exactly. Equity is key. Everyone should have access to digital literacy and affordable essential services, regardless of income or tech savviness.
So smart cities aren't just about technology, they must also be inclusive and equitable.
Absolutely. One of the biggest changes could be more compact, walkable, self-sufficient urban environments. Cities like the Line or Woven City show how sustainability and green transportation can be integral to urban planning.
That's a huge shift from today's sprawling city. What about jobs? Won't automation put people out of work?
Some industries will change, but history shows that new technology creates new opportunities. Smart cities will need professionals in fields like data analytics, cybersecurity, urban planning, and renewable energy.
So it's about adapting to new skills rather than replacing people entirely.
Exactly. Humans and technology working together for greater efficiency and productivity. And smart cities will also tackle environmental challenges.
Cities are a big contributor to pollution and climate change. Smart solutions could really make a difference.
Definitely. By optimizing energy use, reducing traffic, and improving waste management, smart cities can significantly lower environmental impact.
Cleaner air, less noise pollution, more green spaces, it's a better quality of life.
And with renewable energy integration, like solar panels on buildings and smart grids managing energy demand in real time, we can make cities sustainable.
It's a hopeful vision, but we need to think about the ethical implications and unintended consequences of such rapid change.
Exactly. Technology is just a tool. It's up to us to use it responsibly. Smart cities will succeed only if we balance innovation, social responsibility, and environmental sustainability.
Well said. Wow. We've covered so much ground today, from the massive scale of smart city projects and their investments to how they could redefine daily life and reshape urban landscapes. It's incredible to see how interconnected everything is.
Absolutely. Smart cities combine technology, urban planning, sustainability, social equity, and economics, each influencing the other like pieces of a giant puzzle.
Exactly. It's inspiring to think about the possibilities. If you were designing the perfect smart city, what would be your top priorities?
For me, it's sustainability, accessibility, and community. A city powered by renewable energy, with green spaces and efficient, affordable public transportation for everyone, would be ideal.
That's a fantastic vision. I'd add personalization through AI, cities that adapt to individual needs. Imagine systems recommending parks for nature lovers or events for social butterflies, creating a tailored experience while fostering community engagement.
A city that evolves with its residents while maintaining a sense of community sounds like the future we should aim for. At its core, a truly smart city prioritizes its citizens' well-being, sustainability, and happiness.
Well said. Well, this brings us to the end of today's deep dive. We explored the Internet of Things, smart cities, and how AI and data converge to create innovative solutions. From IoT's high-level architecture to its applications in creating green, sustainable cities, it's clear that the future of urban living is already taking shape.
But this is just the beginning of the conversation. In the next episode, we'll dive into AI systems and smart cities, the obstacles in IoT adoption, and explore the future growth and hype around IoT.
Thanks for joining us on this journey into the transformative world of IoT, AI, and smart cities. Until next time, stay curious and keep exploring the possibilities. Together, we can help shape smarter, greener, and more inclusive cities for the future. See you next time.